Good day, dear colleagues. The title of my presentation is Generating DVB-S2 Signals by Application of New End Blade RFX40 SDR Transceiver. Nowadays, many European operators of direct broadcast satellite systems made a transition to the application of DVB-S2 standard instead of DVB-S standard. DVB-S2 standard was developed in 2003 by the DVB project group and ratified by ECI in March 2005. It's intended to transmit television programs of standard definition, high definition, including the usage of modern H264 and H265, so-called advanced video coding and high-efficient video coding codecs for ultra-high definition TV UHD TV. DVB-S2 standard has a high flexibility and provides the following advantages over DVB-S. The first is a more powerful coding system based on BCH and LDPC codes. The second is the advanced modulation formats such as QPSK, 8PSK, 16 APSK, 32 APSK. The third is the extended FEC rate format such as 1/4, 1/3, 2/5, 1/2, 8/9, and so on, which allow to ensure signal reception for small values of the signal-to-noise ratio. And the fourth is the improved role of coefficient alpha, which equal to 0.25 and 0.2. The main manufacturers of DVB-S2 standard modulators are such companies as Mutech, DECTEC, Redyne Constream, Novelsat, and others. However, such modulators are multifunctional professional devices, but cost of which is very high. At the same time, in the modern telecommunications market, there are such software-defined radio manufacturers as Atos Research, New End, Lime SDR, Hack RF, whose transceivers can be used to generate digital television signals of various standards, including the DVB-S2 standard. This slide presents the model and the price of the professional DVB-S2 modulators and the model name and the price of the SDR transceivers which can be used for generation of DVB-S2 signals. So the aim of my presentation is: the first is the assessment of MPAG transfer stream bitrate gain for various values of DVB-S2 roll-off factors. The second is to consider the features of DVB-S2 digital TV signal generation from a multi-program MPAG transfer stream using New End Blade RFX40 SDR transceiver and the GNU radio software environment. And the third is the assessment of the quality of the generated DVB-S2 signal. The table at this slide presents the roll-off factor values for various satellite standards. As we can see, DVB-S and DVB-S2 standard uses only 3 values of roll-off factor, such as 20, 25, and 45%. The most sophisticated standards, such as DVB-S2X, uses 5, 10, and 15% roll-off factor values, and Novelsat NS4 standard also use 2%, which is equal to 0.02 roll-off factor value. Such small roll-off factor values leads to increased spectral efficiency in the bandwidth of 1 Hz for standards DVB-S 2x and novel SAT in comparison with DVB-S2 standard. So what is it roll-off factor? Roll-off factor is the parameter which impacts on the shape of spectrum of DVB-S2 signal. As we can see from the picture, roll-off reduction can decrease utilization of transponder bandwidth. From the other side, roll-off reduction allows to increase channel capacity, bitrate or symbol rate of the transport stream for the same transponder bandwidth. Results of calculation shows that the spectrum reduction of DVB-S2 signal after transition from roll-off factor value 0.2 to 0.1 according to this formula is equal to 8.3%. That means if we have transport stream with symbol rate 19 megasymbol per second, the spectrum bandwidth for roll-off factor 0.2 is equal to 22.8 MHz, and the spectrum bandwidth for roll-off factor 0.1 is equal to 20.9 MHz. So we have spectrum decrease approximately 1.8 MHz. Spectrum reduction of DVB-S2 signal after migration from roll-off factor value of 0.2 to 0.05 in accordance with this formula is 12.5%. So for the same symbol rate 19 megasymbol per second, we have spectrum decrease of DVB signal is approximately 2.95 megahertz. This decreasement of DVB-S2 signal bandwidth we can watch at the spectrogram of DVB signal which was measured for the various values of roll-off factor. Assessment of MPAG transport stream bitrate gain for various roll-off values for the constant value of transponder bandwidth delta F shows that for the case when we have transition from roll-off factor which equal 0.2 to form factor 0.1, the bitrate gain of transport stream approximately 8.1%, and for the case of transition from roll-off factor 0.2 to roll-off factor 0.5, this bitrate gain of transport stream approximately 14.3%. Results of calculation of increasement of transport stream bitrate for various roll-off factor values such as 0.1 and 0.05 you can see in this table. This calculation was made for QPSK and 8PSK modulation for transport stream symbol rates 2, 5, 10, 15 and 18 megasymbols per second. The bitrate increasement mathematically was calculated using this formula. This slide demonstrates the block diagram and photo of the Blade RF-X40 transceiver. The main technical characteristic of the Blade RF-X40 transceiver: output frequency can tune from 300 MHz to 3.8 GHz. Full duplex 40 megasimul per second and 12-bit quadrature sampling. Typical transceiver output power is 6 dBm. There are 9 main stages in order to generate DVB-S2 signal using Blade RF-X40 SDR transceiver. The first stage is the transport stream generation. The second is installing SDR transceiver libraries and drivers. The third is the setting of the basic parameters of the transmission path of the receiver. The fourth is the calibration of the IQ channels of the transceiver transmission path. The next is installing the GNU radio software environment and related expansion package. The next is the synthesis of the software model of the DVB-S2 modulator in the GNU radio environment. The seventh is the compiling a modulator software model in the GNU radio environment and loading its code into SDR transceiver. The eighth is the measurement of the parameters of the DVB-S2 signal generated by Blade RF-X40. And the ninth is the parameters correction of the DVB-S2 modulator program model in the GNU radio. One of the main stages for generating DVB-S2 signal is the calibration of the IQ channels of the transmission paths of the transceiver. Here you can see the power spectrum of the harmonic signal at the output of SDR transceiver before and after calibration of IQ channel. And this picture presents the QPSK signal constellation as the output of transceiver before calibration and after calibration. DVB-S2 modulator flow chart for GNU radio was created by Ron Economos in 2014 and located at the link in GitHub repository. This model consists of blocks of constant parameters, block of the tuning parameters, and block of the modulator. The block of modulator consists of file source, is a transport stream, baseband header block, baseband scrambler, BCH encoder, LDPC encoder, interleaver block, DVB-S2X modulator block, physical layer frame block, fast Fourier transform filter, and Osmocom sync block. This slide illustrates block diagram for measuring parameters of the DVB-S2 signal generated by Blade RF-X40 SDR transceiver. For measuring a signal constellation, we use Prof 7040 DVB-S2 receiver and software named CrazyScan. Below, as this slide, you can see the constellation diagram and its parameter for QPSK modulation, and constellation diagram for 8 PSK modulation and its parameter. Table as this slide illustrates measurement of signal noise ratio for various values of roll-off factor parameters. As we can see from this measurement, the signal noise ratio is decreasing when roll-off factor also decreases. The dependence of signal noise ratio from roll-off factor is illustrated graphically for QPSK and 8PSK modulation. As we can see, when we reduce roll-off factor in order to decrease bandwidth of the signal noise ratio is reduced approximately 2 or 3 dB. Here you can see the photo of the test beds for generation and measuring DVB-S2 signal parameters using Blade RFX40 transceiver, and the spectrum of generated signal for roll-off factors of 0.35 and 0.05. Multi-program MPAG transport stream was successfully decoded by Prof DVB-S2 receiver from DVB-S2 signal, which was generated by our Blade RFX40 SDR transceiver. In this picture you can see that transport stream structure consists of 9 TV program, and each TV program was successfully decoded. So, our conclusion. The first, results of tests show the possibility of DVB-S2 signal generation using Blade RFX40 SDR transceiver and GNU radio software, as well as its successful reception using DVB-S2 receiver with a signal noise ratio of at least 24 dB and bit error rate not worse than 10 to minus 8 when using QPSK and 8 PSK modulation with roll-off, which is equal to 0.2. The second, roll-off, which equals less than 0.2, reduces the DVB-S2 signal bandwidth, but leads to the signal noise ratio degradation by approximately 2 or 3 decibel. The third, for future investigation, it's interesting to study the signal noise ratio and Bayer dependence for various roll-off values and other types of modulation of the DVB-S2 standard, namely 16 APSK and 32 APSK using Blade RF X40 SDR transceiver.